So I thought I'd have a slightly different session today, and we just talk about assignment 1 especially, which was done quite well by quite a lot of people, and not so well by quite a few as well, as we'd probably expect. I think partly it's my fault because I'm not sure even I knew exactly what you should be doing, but as I was marking it, I did sort of crystallize exactly what I thought was quite a good approach, and I think also I recommend it as a general approach, and some of you did it like this anyway. So let me say a few things about what I might have done. So there are certainly lots of approaches in writing this kind of a report. So let me write that down first. But there are lots of different approaches to see how well this is actually focused. Where's the corner? Up there. Oh, right. Okay. So, right. Let's focus that a bit better. Okay. So, first of all, there are lots of ways of writing a report. Okay, and many of you chose different ways, which is fine. I guess one way that I'll recommend now is to point out that in a statistical report there are going to be 3 stages generally. So 3 stages for doing a statistical study. Thank you. Let's go the other way then. Let's just move it that way. Something like that perhaps, and we'll move that like that a bit more. How about that? Yes, okay, great. Thank you. So there are going to be 3 stages for doing a statistical study. So first of all, get your data set. So you collect the data and form the data set. Secondly, analyze it. And thirdly, you're going to publish it in some form. So publish your findings. And this is going to be true in academia, where you're writing reports, or it's going to be true in the jobs. Or again, you've got to write some form of a business report. Now, certainly in academia, there's been a bit of a problem in some sense. I mean, in some areas, it might even be called a crisis, even. But with the traditional model of academic publishing, it's only actually that final step that you can really see. So you can only actually see that final published version. And I think this has actually caused some problems in the various areas of social science and so on, because any reader can't actually check what's been written. So the reader can't check anything really, because they don't have access to the data set, and also all the analysis. all they see is the final published version that says we did this study and found a p-value of 0.09 or something, and that's slightly significant, but not not enough. And this has now led on to the idea of reproducible research. You would have chosen a red pen, that doesn't work. Okay, to reproducible research. Let's hope the green one works. Reproducible research. So the idea here is that the information is all made available in some public form. To your data set, all the analysis, and the final results. So this is motivated the idea of notebooks, Jupyter notebooks, and R Markdown notebooks. And these are here just to be a single document that has that includes your data set, includes all your analysis, and then you can also write in some text as well. So it includes everything. So it includes the data set. It includes the analysis that you did, and also your views and your commentary on the analysis and what you found. So your commentary. And certainly our Markdown documents are fairly easily exportable into LaTeX and into PDF. So those are, in some sense, even better than the Jupyter notebooks. But the main idea, though, I'll write it in green again, is to write so that your reader can reproduce what you've done. So readers can reproduce what you've done. Okay. So in some sense, so when you write some report, I'll recommend anyway, and as I say, you don't have to do it. There are lots of ways of doing these, but it's almost like a recipe book. So every recipe you start out by listing your ingredients, and after that you'll say what you do with the ingredients. And maybe at the end there's also a serving suggestion or something, some final conclusion that ends things up. So I recommend this general approach to a report writing, and I guess I'd assume that this is in the MSc. Because second and third year distance learners are certainly doing this general approach, but it was rather less obvious in the first year residential students. So maybe you've not been introduced to these ideas yet. So I think you should start with an introduction. And as I say, it's going to look a bit like a recipe in a cookbook, and we're going to start out by writing down our ingredients almost. So first of all then, so step one, I think you should be explaining how you find your data set, so where it comes from. So how to find the data set. So the idea here is that if any reader is going to try and do exactly the same analysis, so they can start off by writing down exactly this data set. So I might recommend starting with something like, I don't know, the data set countries. How's my handwriting, by the way? It's a good reason why I generally use slides in the other lectures, but can people read my handwriting? I can try and write more neatly if it's easier. I'll try and write more neatly. So, I mean, maybe you'll start by something like the data set countries consists of 18 variables for 158 countries. Taken from the CIA World Factbook. And that then gives some reference to where you can find it, to where any reader might try and find this. So http / something or other. Okay. So that kind of thing, it's telling the reader where they can find all the data. I know I gave it to you, and I know no one else is really going to read this, but it's just a reasonable practice, I think, in the writing reports. Okay, so the data set consists of 18 variables for 158 countries, taken from this World Factbook thing. And then you might add another sentence, if you've got room, say the variables are relating to economic, health, and the geographical factors, if you like. But so you didn't write too much more than that. After all, I've already listed them for you in the project brief here. You could actually list them all in a more extended project, but there's not really that much point in this case, I think. After that, maybe step 2. I think you should say something here maybe about which questions that you're interested in studying. So again, you're helping the reader. You're trying to orient them and to point them in the same direction that you're going. So here I gave you this wonderful data set. There were massive of things that you might have done. I got the impression some of you just thought of a question immediately and they kind of launched into it, so without really playing with that data set and actually asking what's a really interesting question here. Maybe I'm wrong, but So with our data set here, so with this data set, you could start by exploring it. Explore it first. So explore it first. Try to find interesting things about it. Okay. So try to find things that look interesting. And occasionally you asked a question and kind of answered it, and I thought, well, yeah, fine, no, you did answer it, but there are probably more interesting things that you might have asked, but that's okay. Right. So if you choose a question straight away, there's a danger that the answer might not be that interesting, that's all. So the answer might not be very interesting. So just, I was so hoping really you'd play around with it, think, well, that looks actually very interesting, to try and ask a question and answer it. And some of you obviously did, but not everyone, I think. Okay. Oh dear. Am I going too low? Tell me. Let's just move the visualizer up a bit. Okay. There we go. Right. Yes. So if you chose a question straight away, yeah, maybe it was interesting and maybe not. I mean, maybe you were lucky. Okay. So after that, I think, also I think is part of your introduction still, say what you must do with your variables and your data to answer your question. So in order to study your question or questions, you may need to pre-process your data, and you should tell the reader how you're doing it and how they should do it. Okay, so you are trying to make it sure that you're giving enough information to the reader that they can do the same thing that you're doing. That's part of this reproducibility philosophy, if you like. So you might want to pre-process the data. And so there are all sorts of things here that this might involve, some of which aren't really affected in our country's data set, but for example, our data may have some missing values. So missing values. Now here we didn't have any of those, but if there are any, you should write down what you're doing to deal with these. Are you filling with these missing values? Are you ignoring those for some purposes and not others? So there are various things here that you should say. You may want to clean your data. And here again, you didn't really need it to do any of this either. So last year, I to the MSc project, which you're not doing this year, and it was a really good one. It may one day appear in this book of mine if it ever comes up. I listed in 50 European languages the words of the numbers 1, 2, 3, 4, 5 up to 10, and said, can you rediscover all the usual linguistic groupings between countries? So, in that example, there certainly was some data cleaning needed. What did you do with the languages which aren't in the Roman script? The Russian was there, and the Russian 2 is dva. That needed changing into dva, and other languages have accents. So 5 in German is 5. Is that really a U or not? Well, if you've got expert knowledge of German, you know that really you should be doing FUE NF. But that's slightly unfair, really, because you probably don't have expert knowledge of all those 50 languages, and maybe you should be being consistent and simply changing it into funf. So there's all sorts of things here that you should think about and to work out to what you might do. Now, luckily here you didn't really need to fill in any missing values or clean any data, but so we did have a fairly large data set, and probably it's more useful to choose a subset of features or a subset of countries. Rather than using all 158 countries or all 18 variables. I mean, maybe you should just be doing, I don't know, Western Europe or Southeast Asia or something, and only looking at some of the variables. There's all sorts of interesting questions that you might have asked, and many of you did, in fact. You may need to define new variables. And so this was something that was probably done less than I was expecting in some ways. I mean, surely you can't really compare the number of mobile phones in China and the number of mobile phones in a rather smaller country like, I don't know, Luxembourg or something. And I mean, a much more sensible basis of the comparison is to divide the mobile phones by the population or something. So e.g. use mobile phones per person. Okay. Or internet per person, or GDP per person, or roads per a square kilometre, or I don't know. I'm sure you can think of other things here. So with all of these, so in each case, explain what you're doing. And again, we're thinking of this being a bit like a cookbook again. We're trying to tell the reader what they should do to do the same analysis. And I guess there's an optional step 4 here, which is to briefly mention the ideas that you'll use. So briefly mention that you'll use a PCA and techniques like PCA. And that's optional. I'm going to talk about it anyway. So that's okay. So the idea now is that your reader can read the introduction and can get exactly the same data that you're working with. Okay. So we'll have the main part. I'll say a few things here. To be clear what you're doing at all times. So hopefully at every stage your reader can do exactly the same thing. So they can work out which variables that you're using, which observations that you're working with, and so on. So e.g. which its features and variables are in play at any time. Features and observations are being used. So I'd also say that it's good to give the reader enough information that they can work out how you're getting your conclusions. So, for example, in a PCA, you're kind of trying to write all your variables, or you're trying to write down your principal components as being linear combinations of the variables, and to then interpret those. So, to do that interpretation, it's certainly useful to have a table of loadings. If you're just working with the PCs 1 and 2, a biplot is a reasonable substitute, and you can see from where the arrows are pointing what the contributions are of each of the variables. If you're using a graph, so graphs, these were done reasonably well, actually, on the whole, but to once again, there are exceptions. Graphs should be communicating information. they're not really just they're decorative things. They're to the output of some command, but they're really there for some purpose. What can the reader get from the graphs? So, for example, make sure that they're large enough. I would say that on the whole, your graphs were too small more often than too big. I would say that a good third of you made your graphs a bit too small. It might be my eyesight. I'm getting on a bit now. And only 2 or 3 of you made your graphs too big, I think. In particular, it was often hard to read the labels and the scales on axes. Probably getting too low, am I? Yeah, there we go. Thank you. I didn't say, did you? Okay, but to make them bigger, on the whole, avoid overplotting if you can. There were really quite a large number of biplots that just had a massive ink in the centre. That wasn't too important here because it was really the arrows which were the important thing, and you could you can still identify the outliers anyway. So that was actually not that bad, but try and avoid it. I mean, just occasionally there were arrows in the biplots where the variable names were on top of each other. That was actually reasonably common, in fact. Use colours wisely. Or in other words, take advantage of them. Not every graph did that. Some graphs had scales to kind of indicate a third variable, where the scale went from a dark blue down to medium blue, and it was not always that easy to work out exactly what what the value of the third variable was. Yeah. To label axes again. So label axes legibly and sensibly. On the whole, most of you did it okay, right? But everyone can do a few things better. Now, on the final part for level 4 and MSc students, when you're doing a t-squared test, so using statistical tests is like using a mathematical theorem. Just using statistical tests is like using a theorem. There are hypotheses. which it should be satisfied. So, in particular, yes, Rita. Yes, thank you. Well done. Right, yeah. So, in exactly the same way that theorems have hypotheses and it's part of their statements, and then you get to conclusions from them. The t-squared test essentially requires that the two groups are normally distributed with the same variance matrix. So you should try and actually verify that, or indicate at least that you thought about it. I don't actually care in the example here if the hypotheses are actually satisfied, but it would have been good if for you to demonstrated that you thought about it. Probably only about 3 people out of 60 have actually explicitly tried to verify that their data were normally distributed and had similar variances. Carson, do you want to make any comments on the main parts?
Okay, so when the introduction, you mean the main part, not the introduction part itself. The main part, I found that a lot of people did a lot of plots which didn't say anything. We didn't actually refer back to this in the main text. Okay, so I mean, the problem with all of this, of course, I mean, Fred is absolutely right in his writing, but of course, there's only 4 pages to write down the information. And for example, if you want to say 4 or 5 plots, they all should be readable. If you don't have the space, put them in an appendix. In the main text, you can absolutely refer to the appendix that plots. It's not so to the important plots, 2, 3, maybe 4 in text, but anything you want to say additionally, you need evidence, you put them in an appendix. That is maybe what I would say about the main part. And of course, make the plots big enough. Often you have labels on them because it's important to read. Some people put all the countries in the whiteboard. There was a big lump of letters. I couldn't, we couldn't really identify much. So that's about the main part. Introduction, I would have something else to say, but maybe you can learn it later.
Okay. So finally, it's generally useful to just to tell the reader to the end just a summary of what you've done, of your findings. It's fairly common in this final conclusion also to suggest future directions. So directions for more work in the same for more work, more analysis. I mean, that's kind of optional. In the in the level 4 and MSc version, where you kind of had two tasks. It's entirely reasonable to have a separate conclusion in each part to just a final sentence or two. If you manage to really weave your two parts together and have have your final task really following on from the previous part, then by all means have a single conclusion. So anyway, those are my thoughts anyway of how I think your reports ought to look more like cookbooks and things. Just trying to help the reader be able to reproduce your analysis. As I say, actually I mean, many reports were actually really good, yeah, I very much enjoyed reading some of them. I mean, many of them, in fact. So.
So, I mean, I agree with Fraser. I mean, there were a lot of very good things to read. Others were, you know. So in the introduction, it's very important that you say which question you want to answer. So I had quite a few which just said, oh, I played with the data. I didn't find anything particular. Now I'm doing this. Okay, so in which case you don't say what you try to do. You can just be just in the sentence, you can say possibly, after initially looking at the data, I found an interesting question I want to follow up. What to do in this report is to do, for example, health data or economical data. But don't say that, you know, what you have done and which didn't work. If you do this, there must be a reason why you think the analysis you haven't done is interesting. Then it would be possibly interesting. But just don't say in the introduction, I tried this and this, it didn't work, therefore I concentrate on this because I get a result. It didn't, I mean, there were quite a few of those. More than a handful, which I thought there was an initial data exploration. I mean, it's looking for what question can you answer, but you have to formulate it slightly differently. So there was a lot of space wasted and given all the plots with all the different correlations between the different variables, and there was I can't see much, so I move on. That doesn't really help. So yeah, that's one thing which I found on the introductory part, if there was any effort at all.
So do you have any questions? Also, we have to work out how we're going to get your marks back. What's a good way of getting marks back? Though we haven't really checked our marks properly yet, so all our marks are provisional. Everything is marked. We've got some very early marks. So we'll be checking our marking and try to agree marks later this week. And so then we might be scaling anyway. I've got some photocopies of our current mark sheets. So I don't really want to hand those out in some sense, but on the other hand, it might be useful given that assignment 2 is coming up. So I guess if you come to the front and tell me whether you're doing 369 or 469 or 6019 and show me your U card as our mark sheets are all done by registration numbers, then I will show you where your mark sheets. But I do stress that the marks will almost certainly change a bit. Okay, so, but to give you some kind of idea, if that's what people might want. I mean, if people want to find their marks, do you want to know your marks? I don't know. Okay. Alternatively, and while you're doing that, if you've got any thoughts about the module and how it should run next year, if you jot those down on a piece of paper and leave them here, that'd be good as well. As I said yesterday, I think the most important part of the module is going through the lab sheets, and me standing in front could be replaced by video lectures, and we could have instead some lab sessions. I had no idea how many people were going to sign up for the module. It might have been 30 and it might have been 200, and that's so one reason why I was a bit cautious about having lab sessions. And it also has been extremely useful to lecture everything once all the way through anyway. But any thoughts like that you have, do let me know. Right, okay, so if you want to know your marks, got some mark sheets. Oh, no, I haven't. Is it that one or the other one?